Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazim. Now, I'm going to present about our final project for this subject, which is Power System Protection Technology. And next is agenda. This is our agenda that we are going to present. First is team members. Second is introduction. Third, problem statement. Fourth, simulation and calculation. And the last one is summary. Okay, now first we're going to the team members. Okay, this is our group organization from group 5. First is our project manager, which is Muhammad Faris bin Hamidin, DN200066. The scope for our manager is part A and minute of meeting. Next is our relay technician, which is Muhammad Luman Hakim bin Zainuddin, DN200060, and the scope for Luman Hakim is part B and report. Next is me, Muhammad Nazim bin Subki, as a control system engineer, and the scope is part C and video editor. Next is Muhammad Faris Aiman bin Muhammad Nizam, DN200049, as a power system engineer for our project. The scope for Faris Aiman is part B and project design. And the last one is our protection engineer, which is Ahmad Fikri bin Rosman, DN200093. The scope for our protection engineer is video and project design. Okay, now we are going to the introduction. Okay, first of all, protective relays is a device that detect the abnormal condition, which is fault, in our electrical power system. Once the fault is detected, this protective relay will send a signal to the circuit breaker. Then the circuit breaker will open the faulty section for our electrical power system for isolating it from the rest of the system. And then this protection system used to avoid from additional damage to the equipment and power outages.
Hello and Assalamualaikum. My name is Ahmad Fikri bin Rosman, DN200093. Today I'm going to present about a problem statement. Okay, this is our problem statement. So for the power system protection, it need to design to implement in the system that quickly detect the fault and isolate it from the power system to minimize the damage that caused by the fault. Okay, and this type is require a reliable and efficient coordination for the protective device and equipment, and it also need a regular maintenance and use of advanced communication for and monitoring system. Okay, next is the simulation and calculation. Okay, this is our circuit diagram, and at the top is our single line diagram. As we can see, we have generator 1, and at the bus 1 we have guide with two circuit breaker, which is CB1 and CB3, and under that bus 1 we have load 1. Okay, we also have transformer, which is 50 MVA. At bus 3 we have load 3, which also guide with two circuit breaker, CB4 and CB5. At bus 4 also same, we have load 4 and guide with two circuit breaker, same as the 5. And we on the right side of the circuit diagram we have generator, second generator. Okay, we also can see the fault happen at bus 1. So when the fault happen at bus 1, the circuit breaker 1 and 3 will be triggered there to isolate the bus 1 from the power system.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Aiman bin Muhammad Nizam. I'm going to present about the calculation. The type of relay that we use in this project is inverse infinite minimum time, IDMT over current relay. For the calculation, first step we need to find the full load current with formula transformer in MVA over Z3 multiplied by the voltage. Next, we need to find the pickup current. We formula full load current multiplied by 1.3. The answer of pickup current in HV is 568.607. Next, the pickup current for LV is 3411.616. Next, this is the formula for time multiplier setting, TMS. For relay 1, we set the timer is 2.1 and the TMS and the calculation of the TMS of relay 1 is 0.47. For relay 2, we set the timer is 1.5 and the TMS we got 0.33. For the relay 3, the timer we set is 1 second and the TMS is negative 0.229. And the last is relay 4. For relay 4, the timer that we set is 0.5 and the TMS is negative 0.13.
Assalamualaikum, my name is Muhammad Lukman Hakim bin Zainuddin and I will present to you for a summary of this project. So, power protection fault analysis involves identifying, analyzing and mitigating faults in power system through the use of protective relay. It is a critical process that helps ensure the safe, reliable and efficient operation of power systems. Fault analysis typically involves identifying the source and location of a fault, determining the type and magnitude of the fault, and selecting and configuring the appropriate protective devices to isolate the fault and prevent further damage to the system. This process can be accomplished through a combination of manual analysis and automated tools such as power system simulation software. And that's all from us. Thank you.